Okay, so good afternoon, everyone. Um, we are going to discuss about the module 10 of our um, CE 324 numerical solutions to civil engineering problems, which is entitled numerical differentiation. So, you have already knew how to differentiate functions no before. Differentiation is the process that we use dealing in differential calculus, which is calculus 1. So here in module 10, we will you have known analytic methods no, which is atong gidiscuss sa calculus 1 or differential calculus. That is an analytic method which is much accurate in terms of representation or analysis, but in terms of actual computation, no, with regards to computing aids, just like computers, no, and calculators, um, it's quite complicated to solve for, no, using those computing aids. That's why the scientists before, or the mathematicians before, and even the engineers use this method, no, enable for them to a a create a computing aids that is able to calculate differential differential values using physical computation, no, which is the numerical differentiation. Okay, so here's the outline of our discussion. First is the introduction to numerical differentiation. Second is about the equations in numerical differentiation, and then we have these unequally spaced derivatives, and then we have some examples. Then just don't mind about the announcement, because I think this is announcement for the class of engineer Galgo, Galdo, no? So, but I haven't removed it in the PowerPoint presentation. Okay, so although we still have announcement for our class, no, our classes, but it is different in what is written in the PowerPoint. Okay. So let's have an introduction to numerical differentiation. So calculus is the mathematics of change. So that's the basic definition or the layman definition of calculus. So calculus is the mathematics of change. So and when we say differentiation, that refers to rate of change, right? So differentiation means rate of change. That's why we have this delta y over delta x. Okay, so that is the um, that refers, or actually differential equation is limit of uh, change of y over change of x as change of x approaches um, 0, right? So that's the um, numerical, the calculus, the analytical equivalent of differentiation. So in that case, when we say um, delta y or delta x, that refers to change. Okay, so that's basically the definition of calculus. No, so for differential calculus, that is the representation of change. So because engineers must continuously deal with systems and processes that change, calculus is an essential tool of our profession. So mathematically, the derivative, which is the fundamental vehicle for differentiation, represents the rate of change of an independent variable with respect to an independent variable. So that's just like what I've said, no? Derivative is just the rate of change. So okay. So here are some representation of uh, changes or rate of changes in a function. For example, you have this graph of function which is color blue. So this is f of xi. Okay, so f of x, this is f of x. and then you have this certain value xi, and another value xi plus delta x, wherein the difference between xi and xi plus delta x is delta x, and then the difference between f of xi, which is function f of x substituted xi. Okay, so I think there's somebody who wants to enter. Okay, so on the first illustration, we have this f of xi plus x plus delta x, which refers to the function f of x substituted with xi plus delta x. Okay, or just simply xi plus 1. This is xi plus 1, given that the difference between xi and xi plus 1 is just delta x. Okay, so um, the difference between those two functions are this delta y. Okay, and then we know that just like I've said earlier, that delta y over delta x, as delta x approaches to 0, is equal to the derivatives. So this whole representation, or the slope in between these two, could be an approximate for the derivatives. Okay, and as I discussed in the first meeting, numerical solution is a method of approximation, right? So in numerical differentiation, you just approximate the value of the slope when you once you have the
Excuse me, sir.
yes.
Na magpa-accept, sir.
Okay, so let's continue. So in the first illustration, the difference between in terms of xi, if you're going to observe, if our what you call this, point of interest is xi, and then let's say this is the approximation of the derivatives of f of x at xi, right? Because when we want to know the derivatives at a certain point, we will take the derivatives of the function, and then once we have the derivatives of the function, we will just substitute the the point of interest, such as the xi. Okay, so if we are going to observe, supposedly, uh, excuse me, I cannot, um, okay, I cannot open the, sorry, I cannot open the file. So, okay. Sorry for the interruption, but I cannot open the um, pen function of the file or the slideshow. So, I don't know what's the reason. Why can't I open um, full screen? So let's try to have full screen. I think it will have the, para at least later on ma-appeal siya. Naka-oy. numerical methods for solving ODEs, then the initial value problems, then we will have the Euler's method, and then the modified Euler's method. So, okay. So, what is ordinary differential equation? So, differential equations, actually, you already have gone through differential equations, right? So, differential equations appear in all branches of science and engineering as they provide detailed information regarding distributions or variations of the independent variable as a function of the independent variable. Because in actual jud, guys, ang ato jud gina-applyan is puno actually our world is full of ordinary of differential equations, no, puno jud siya. Sugod ta kanang for example kanang sa billiard, actually kanang pagkuha nimo sa kanang pagtira nimo sa cue ball, no, kanang pag hit nimo sa cue ball, nana siya certain speed sa imong pag-hit or force sa imong pag-hit, and then nana siya certain impact, and then kana siya na impact is nana siya movement, no. So and then napad siya consideration sa friction, na siya consideration sa speed sa ball, position sa other ball na maigo, then ang distribution dayon sa kuan sa movement. So katong iyang mga motion, pwede nimo na siya i-simulate, no? Using values of differential equations. Actually, those values including position, and then speed of the ball, then the force, no? Kana siya, actually, those are, for example, speed is already a differential of x, di ba? Speed is already a differential of x. Tama? Tama, di ba? Or velocity, di ba? Because v is equal to dx over time. And then we have this certain position. So, it means dx over dt is equal to v. And then, given that you have a force on the ball, so it means that there's an acceleration. And acceleration is the second derivatives of a position. No? So, based on that scenario, you already have extracted three two differential equations. I mean differential values, which is the first and second derivatives of x, which is formally speaking in physics that is velocity and acceleration. So that's an example of a scenario wherein differential equation is existent, no? So kanang mga computer simulation sa billiard and other kind of simulation, ga-involve na sila og differential equations, no? So parehang friction sa kuan sa table, including na sa mga considerations sa differential equation. So in the case of engineering, so kanang mga flow analysis, so that involves differential equation. So mo nang important ning differential equations. So and then this provide detailed information regarding distributions or variation of the dependent variable as a function of the independent variable. So a differential equation is an equation that contains derivatives of an unknown function. The solution is the function that satisfies the differential equation. So just like what we do in differential equation, di ba, ginasolve man nato kung say value jud sa f of x or value sa y, di ba? In terms of x. Mao ba yan ang final answer nato niya, di ba? Y is equal to a function of x, no? Plus c infinite, no? Mao ba yan na siyang differential equations, ginasolve nato sa differential equations. So, an ordinary differential equation is any relation between a function of a single independent variable and its derivatives. So, pag ang imong derivatives or differential equation contains only one independent variable, so say x, no? So, that is considered an ordinary differential equation. But if you have x1 and then you also have x2, which is two independent variable, no, not correlated on each other, so that's the time that you cannot consider it an ordinary differential equation. That is in general a differential equation. Okay? So, for example, if x is the independent variable and y is the dependent variable, the ODE has combinations of the variable x, y, and dy over dx, or dy d squared y over dx, no? Depende na siya kung pila ka derive pila na pila nimo siya gi-derive sa imong equations or differential equation. So on the example, no, sa illustration, that is m being the m or the mass, no, mass being the dependent variable, and then the time being the independent variable, no. So there is no other other independent variable niya input sa iya but the time, but only the time, no. So we have this h, and then we have this a, or area of the tank. So then we have this area of the hole, which is the are just component of the derivatives, no. So we have this dm over dt, which is referring to the mass flow, no, mass flow equation, mass flow value, no. So kana siya, or quantity, or discharge quantity in terms of mass. So, okay. So, ODEs are classified in terms of order and degree. So, the order of an ODE is the same as the highest derivatives with the degree is the power of the highest derivative. So, pag mayroong tag order, that is the highest derivative. For example, first derivative, if there is first derivative, second derivative, and third derivative, it means that the order is 3 because the highest derivative is third derivative. Okay? So that is order 3. And then whatever the exponent of that derivative, that is considered the degree of the ODE. Okay? So, for example, that third derivative is raised to the power of 4. It means that the degree of the differential equations is 4. Even if the second derivative has fifth exponent, you will be only considering the highest derivative in terms of degree. So, for example, we have this x cubed multiplied by third derivatives of y with respect to x plus x squared times the second derivatives of y with respect to x plus x times the derivatives of y with respect to x plus xy is equal to e raised to the power of x. So the order is 3. And then the degree is 1. Okay? Because the third derivative has only 1 degree. Another example is we have this dy over dx, or the derivatives of y with respect to x, plus 1 quantity raised to the power of 2 plus x squared dy over dx is equal to sine x. So, the order will be 1 because that is only first derivative. Okay, and then the degree is 2 because the first derivative is raised into second power. And please don't disregard in terms of order, disregard the uh, variable variable multiplicand to the derivative, no. So just like this, we have this x squared then x cubed. Regardless if kung kitay mo abot na ni siya x to the fourth, no. So ang imong radyo i-consider is ang exponent aning imong highest degree, no, kana siya. So as you see, degree 1 gihapon, no, even x cubed na siya, x to the power of 3 na siya. So ang inyong i-consider is kaning derivatives jud. So mo ni siya this is the branches of numerical solution for solving ODEs. So we have two types of problems in solving ordinary differential equation. So, based on the given. So, we have these initial value problems and we have these boundary value problems. So, we will be only be dealing with initial value problems in our discussion, no? So, supposedly boundary value problems will be our module 12, but we decided to exclude it in our discussion due to the range of the coverage, no? To shorten the range of coverage, we decided not to include boundary value problems. So, these two types was based on the given, no? So, in initial value problems, the given is of course the initial value. For boundary value problems is of course the given is the boundary. And then we're going to solve for the differential equation using the given. Okay, so under the initial value problems, we have this three, no? We have this Euler's method, modified Euler's method, and we have this Runge-Kutta methods. Okay, so for the first part of our 11A, we will only be dealing with the Euler's method and modified Euler's method. And then for later on, we will be discussing Runge-Kutta methods. So, initial value problems. When as in many application, it is impossible or undesirable to find the exact or analytic solution. Numerical solution can be used to find approximate solutions of initial value problems. So, even other computer, no, kanang kintay kanang ga solve of equation, mga programs day rather. So, na mga internet programs karon just like Pothomath, no? Gasolve na sila mga differential equation and the others, no? Pero ang ilang method is limited lang jud into analytical solution. But analytical solution is also limited pod. So as you notice kanang Pothomath and other programs or applications on websites, magamit po ni sila og numerical solutions, no? Kung kitay di na nila jud ma-solve using analytical solutions. So kana siya. So okay. So an initial value problem is made up of two components. So first is the mathematical model of the process stated in the form of a differential equation. So for example, we have this dy with dy over dt is equal to the function of t and y, where t is greater than 0. And then second, so dapat mo na yung component, no? So you have this mathematical model of process stated in the form of differential equation. Then second, we have this initial value given at some value at the of the independent variable. So dapat na kay initial value sa imong pag-solve. So for example, we have this y sub o. So y sub o, given that the initial value of x is equal to 0, and then the initial value of y is y sub o. Okay? Or any number, no, na mo represent sa y sub o. And then the numerical solution to this initial value problem is a sequence of number. So bali dili lang siya single valued problem, no? This is a sequence of number. So we have this y sub o, y sub 1, y sub 2, and y sub n. So bali step based siya. So from mag-start sa y sub o, then next y sub 1, then next is y sub 2, and then next is y sub 3, and so on and so forth hangtod sa y sub n. Okay? So di lang tan ng y sub tan. Sige, so where for n is greater than or equal to 1, y sub n is the approximation of the exact value y sub t at t is equal to n times h, with h being the distance between consecutive equally spaced t values. So we still have, in every step, h is the same, no? For each step, we're in n is the step value, no? So kana siya. So t is a certain value of x, no? Kanang kitay y, function man siya sa tcy, no? So kana siya. So here's an example, no? Illustrative example. Kung yun sa siya pag-solve. So initially, the value of y is this, y sub o. And then at the first step, we will solve for y sub 1 as an approximate value of t1 being equal to h. Okay? And then the next step, we will be using t2 which is equal to 2h because we will just be adding distance h here and then another distance h here. So 1h plus 1h is equal to 2h. And then we will solve for y sub 2. So that's another value. So that's why it is a sequential number. So next, we will going to solve for T3, which is equal to 3h. So we will just add another h. No? So that this will become 3h. And then we will now solve for y3, and then so on and so forth. y4, y5, no? Until sa atong value na desired. And then, okay. So, we're for, to siya, no? So, this graph is the exact solution. So, this is the exact solution. And then, given you have this initial value, y sub o, these are the approximate solutions. Okay? Based on the steps. So, we have this time steps, which is equal to h. So, one of the methods in solving initial value problems is the Euler's method. So, the Euler's method is the simplest technique for solving first order ODE of the form dy over dx equal to f of x and y with initial condition y sub x1 equal to y sub 1. So it can be formulated as an explicit method or an implicit method. So with explicit formulation, more commonly used. So here's the Euler's explicit method. So Euler's explicit method is a single-step numerical technique for solving a first order ODE. So this is an illustration. So this is the correct solution, y of x function. And then we have this approximation, no, na numerical solution using the slope. Okay? So using this slope, you will approximate the values of this graph by step. So, kana siya. So, where h is the step size. Then, after that, you will have another step to approximate the value. Okay? And then, this gap in between them is the error. Okay, so here are the equations that you can extract from this illustration. So we have xi plus 1 being equal to xi plus h, and then yi plus 1 being equal to y plus yi plus slope multiplied by the h. And then slope is equal to the constant estimating um, dy over dx from xi to xi plus 1. So you can use any methods, no, just like what we do in numerical differentiation to solve for the estimated value of dy over dx from x to xi plus 1. So using the forward difference formula, so in this example, we will be using forward difference formula. So in forward difference formula, slope is equal to dy over dx, or approximately equal to yi plus 1 minus yi over xi plus 1 minus xi, or simply equal to the function of xi and yi. So here's an example. No, we are going to use Euler's explicit method to solve for the ODE dy over dx equals to negative 1.2y plus 7e raised to the power of negative 0.3x. So from x is equal to 0 to x is equal to 2.5. With the initial condition, y is equal to 3, x is equal to 0, and with h is equal to 0.5. Okay, so given we have this ODE dy over dx equals to negative 1.2y plus 7e raised to the power of negative 0.3x. Then our initial value is equal to 0 and 3 for point x1 and y1. And then we have this step size being equal to 0.5. And then we have this equation for xi plus 1 being equal to xi plus h, or simply xi plus 0.5. So then we have yi plus 1 being equal to yi plus f of xi, yi multiplied by h, or simply equal to negative 1.2 yi plus 7e minus 0.3 xi multiplied by 0.5. See, so here's our solution. So we will just be using this equation. So for xi plus 1, this is the equation, xi plus 1, xi plus 0.5. For yi plus 1, we will be using yi plus negative 1.2 y plus 7e raised to the power of negative 0.3 xi times 0.5. So for step 1, we will let I be equal to 1 because that is step 1, no? So that is I is equal to 1. So initially, xi, our value, our approximate, sorry, nairo na ko. So, or our ay nako, lisod kayong RR ba? So, ang ating estimate is x1, no? So, initially x1 is equal to 0. And then x2 is equal to x1 plus 0.5 according to our formula, no? So, kana siya. And then x1 is equal to 0. So, we will just substitute 0 to x1. Then we will have 0 plus 0.5 or simply 0.5. And then for y2, so using our formula, we have y1 plus negative 1.2 y1, y sub 1 plus 7e raised to the power of negative 0.3 x sub 1 multiplied by 0.5. So we will just substitute the initial value of y and x. So that is 3 for y and then 0 for x. So simplifying that expression, we will have 4.7. So that will be our next approximation value. So we have approximation value for x, which is x2, and another another approximation value for y, which is y2. So x2 y2 is equal to 0.5 and 4.7. So for step 2, we have I is equal to 2, then x3 is equal to x2 plus 0.5. So we will just substitute x2, so we have 0.5 plus 0.5, which is simply equal to 1. And then we have y sub 3 equal to y sub 2 plus negative 1.2 y plus 7 e raised to the power of negative 0.3 x2 times 0.5. So we will just substitute the initial value x2 and y2. Then we will have this expression, which is equals to 4.8925 as simplified. Okay? So, in step 2, our next approximation value will be x3 and y3 being equal to 1.0 and 4.8925 respectively. And then for step 3, we have this. So, I will just run through it. So, x4 is equal to 1.5. So, y4 is equal to 4.5499. And then for step 3, x is equal to 2.0, then y is equal to 4.0517. So for step 5, so tama na ta 5 because our problem is only asking for the interval 0 to 2.5. So tama na pud ta 2.5. So that is the step 5, which is I is equal to 5. And then x6 is equal to 2.5. So y6 is equal to 3.5415. So kana siya. So those are the set of values solved using numerical solutions to ODE, or ordinary differential equation. So if you want to know or you want to approximate the function, you may use using these points, no? You can use this point to approximate uh, the y, no, or the f of x function using either interpolation or regression, no, to approximate the function itself, given that you have already these values, no, x and y. Okay, kana siya. So okay, We move on to the modified Euler's method, is there any questions you would like to raise? Any questions? Or walay nasabtan? Charot. Na, manggod. Di ko mo nga wala. Sige, so I think there's no question, no? Calling once, calling twice, calling thrice. Wala na. Sige, okay. So let's move on to modified Euler's method. So modified Euler's method is just quite complicated na siya, no? So you will be involving three steps, no? So first, you will be solving the slope at the beginning of the interval, no? So that's what we do in our in Euler's method, which is the explicit method, no? And then next you will be estimating the slope at the end of the interval, no? So just like this, you will be estimating, no, the slope of this. Okay, so you will just transfer this point to this. Okay, and then by next step is that you will be using the average of those two slope, no? So you have slope here, and then you also has another slope here. Okay, and then you will just take the average of those two. Then you can now solve for uh, the approximate ODE, or values of y at the ODE. Okay, so here's our algorithm. So first we are going to solve for the next value of xi. So that is xi plus 1 equal to xi plus h. So next is calculate for f of xi yi. So that is just this first step in solving Euler's method. And then next is we're going to solve for the value of y using Euler's method, no? So, manto siya. Then next, we are going to calculate for f of xi plus 1 y values of y using Euler's method, I plus 1. And then we will now calculate the solution at x is equal to x plus 1 by getting the by using the slope, no, approximate slope, which is this value, no? So we have this slope, and then we have this another slope. Okay, so this is the values. Okay, kana siya. So okay, so use modified Euler's method to solve for 0 na nun. ODE dy over dx equal to negative 1.2y plus 7e raised to the power of negative 0.3x from x is equal to 0 to x is equal to 2.5 with the initial condition y is equal to 3 plus at x is equal to 0 and with h is equal to 0.5. So same example but different solution. So at this time, we will be solving for numerical solutions of this ODE using modified Euler's method. So here's our solution. So uh, step 1, we have I is equal to 1. So we have already solved this earlier, no? So kana siya. So given na natay f of f of x1, then y1. So, kani siya, mga naman natong isolve ganina, no? So, then we will be using this slope, no? Actually, this is a slope, no? To solve for the approximate, kining approximate nato na value ni y. Okay? So, kani siya, actually, combination ni siya sa interpolation and then, kuan, is it tawag gani? Numerical differentiation, numerical differentiation, no? Combination ni siya. So, kana siya, no? Then we will just substitute the values 3, no? So which is the initial value of y1, and then the values of f of x1, then y1, which is equal to 3.4, and then the value of x2, which is equal to 0.5. Okay, so that y2 is equal to 4.7. So given we have already values of x2 and y2, we can now solve again for f of x2 and y2. Okay, so that is equal to 0.3850. And then y2 is just equal to the formula for modified Euler's method. So that is just the average of these two slopes, no? So the slope of f of x1 and y1, and then f of x2, then y2. So okay. So that is just equal to y. We will just substitute the given values, no? So y1 equal to 3, f of x1 and y1 being equal to 3.4, then f of x2 y2 being equal to 0.3850 over 2, then multiplied by h, which is equal to 0.5. So that is equal to 3.9462. So our x2, y2 is equal to 0.5 and 3.9462 respectively. So that is our step 1. So uh, by using the same algorithm to solve for other steps, no, these are the values obtained. So 0.5, so mani siya, no? Di na nako isa-isa, no? Makita naman siya. So you can try it on your own if you will get this all this number, no? Just to practice lang, no? You will just do the algorithm lang yapon, no? Kana siya, so una x2, then sunod f of x1 plus x1 and y1, so that is just simply the slope, no? Which is mo na siyang ODE itself. Okay, kana siya. So here's another example, no? So this is the Euler explicit method. So kani siya mo ni siyang ilang estimate, no, kung ato i-plot tong atong ma-result kanina. So mo ni siyang na atong na estimate, which sorry mo jud dapat niya ang atong kuan ang function. So mo ning estimate, so as you see sa Euler's explicit method, grabe siya kalayo, no, dako kayo yang error. Pero pag-abot sa modified Euler's method is niduol na siya, no? So that's it. Do you have any questions regarding the first part of ordinary differential equations? Wala? Walay nasabtan. Nabay question? Any questions you would like to raise before we move on to our last topic, Jud, kaning Runge-Kutta? Wala? None? Okay, sige. So, are you ready for for our last topic? Ready na ba? Just raise your hand kung ready na mo or uh, okay. Sige. I think most of you man pod kay ready na, no? There are at least 7 na nag-raise og hands. Most na siya, no? Out of 100. Out of 49. So, ngano ka nang uban asa ka niyang uban? Supposedly dapat 120 mo, no? But there's only 48 na ni attend. So, okay. Kaya na siya. Basta pag-abot sa exam, walay ko anay, no? Inyo man ang kuan. But I hope na maka-learn yapon mo, no? Or basta sa inyo na siya na part, no? Sige. So, okay. Sige. So, let's continue. Stop shares na ako, guys, ah. Okay. So, let's discuss about our next topic for ordinary differential equations, which is the last method no natong discuss for finance, no? So, hopefully na dumduman ni siya tanan. But I don't want to hope jud na hope lang taman, no? Dapat i-materialize jud nato na mas maka-answer ta sa exam, no? Kana siya. So, okay. So here's the outline for our discussion. So um, we will discuss about numerical methods, no? Ato i-review tong mga numerical methods for solving ODEs, and then we will now continue with the discussion on the Runge-Kutta methods. So in Runge-Kutta methods, we have this um, three no na examples na or three nga orders nga atong i-consider. First is the second order, then we have this third order, then we have this fourth order. So as discussed earlier, mo ni siyang atong tanan mo ni siyang mga numerical methods na involved in solving ODEs, no? So at this time we will be discussing about the Runge-Kutta. So kana siya, no? So the initial value problem is made up of two components. We have this mathematical model of process stated in the form of differential equation, and then we have this initial value given at the value of the independent variable. So sinong kakuta same gyapon, nagyapon siya ay two components. So Runge-Kutta methods are a family of single step explicit numerical techniques for solving a first order ODE. As with the Euler's method, it is defined that xi plus 1 is equal to xi plus h, yi plus 1 is equal to yi plus slope times h. So variations of the RK methods differ, so RK is Runge-Kutta, no? Differ in the number of points within the subinterval xi plus 1. So napod jud kay mura ginatawag nga number of points within the subinterval. So given na naka-interval nga katong taas kaayo, so from 0.0 to 0 to 0 sorry 0 to 2.5, which is gibahin-bahin siya into 0.5, 1, then 1.5 at sir makabot sa 2.5. In between pa jud na isimo pa jud na siya hatagan og sub-interval to consider in calculating this slope. So, for second order Runge-Kutta methods, we will be using slope at 2 points. Okay? And then for third order Runge-Kutta methods, we're going to use slope at 3 points. And then for the fourth order, also called the classical Runge-Kutta method, we will be using slope at 4 points. So RK methods give a more accurate solution compared to the simpler Euler's explicit method, and such accuracy increases as the order also increases. So how are we going to solve for that? So we have this general form being equal yi plus 1 being equal to yi plus constant 1 multiplied by k1 plus c2 multiplied by k2 times h, where k is equal to f of xi times yi, then k2 is equal to f of xi plus a2 h, then yi plus b2 k1 h, b21 k1 h. Okay, where c1, c2, a2, and b21 are constants with the values depending on the method used. So under those methods, we have this modified Euler method. So for modified Euler method, we have yi plus 1 equals to yi plus 1 half k1 plus k2. So as you observe, c1 and c2 is equal to 1 half for modified Euler method. And then a2 and b21 is equal to 1. Okay? And then same gyapon siya sa Runge-Kutta, no? So in general, we have k1 being equal to f of xi, yi, and k2 is equal to f of x plus h, then yi plus k1 times h. Okay? And then we have this midpoint method, which is c1 is equal to 0, then c2 is equal to 1, then a2 is equal to 1 half, and then b21 is equal to 1 half. So this time, unlike modified Euler method, you're going to give or to approximate the midpoint of the interval. So as you observe, C1 is equal to 0, then C2 is equal to 1, and then A2 and A1 is equal to 1 half. So the formula for midpoint method will be yi plus 1 is equal to yi plus k2h, where k1 is equal to f of xi, yi, and k2 is equal to f of xi plus 1 half h, yi plus 1 half k1 h. So you will just simply substitute the constants, no? Based sa general form. So, kana siya. And then we have this Yoon's method being equal to C1 is equal to 1 fourth, C2 is equal to 3 fourths, then A2 is equal to 2 thirds, and then B21 is equal to 2 thirds. So yi plus 1 is equal to yi plus quantity 1 fourth times k1 plus 3 fourth times k2 h. So you will just substitute the values for c1 and c2, and then where k1 is equal to f of xi yi, and k2 is equal to f of xi plus 2 thirds h y I plus 2 thirds k1 h. So you will just substitute the values, the constants, no? Sige, so okay. So for third order Runge-Kutta method, so kung kini is tama lang siya kaduha, no? Kini si third order is tama siya katulo. Siyempre, given nga third order na siya. So, kani siya. So, as you see, medyo complicated na siya, no? Kay daghan na siya i-consider nga constant. So, um, the more na daghan imong constants, the more na mas accurate ang imong approximation. So, we have this general form, no? Same gyapon, different siya sa but similar siya. The difference is only that nadugangan na atong constants ug isa, no? So earlier we only add C1 and K1, then C2 and K2, and then at this time we will be adding C3 times K3, no? So marang yang difference sa second order. And then given na natay K3, syempre napud na siya uh, napod na siya i-value, no? So, which is equal siya sa f of xi plus a3h yi plus b31 k1h plus b32 k2h. So we're C1, C2, C3, A2, A3, B21, B31, and B32 are constants with values depending on the methods used. Okay? So for third order Runge-Kutta methods, we have this classical third order RK methods. So for C1, we have 1 over 6, C2 equal to 4 over 6 or 2 thirds, and then C3 equal to 1 over 6. And then A2 is equal to 1 half, A3 is equal to 1, B21 equal to 1 half, B31 equal to negative 1, B32 equals to 2, and then yi plus 1 equals to yi plus 1 over 6 k1 plus 4 k2 plus k3 times h. So that is just by substituting the values of the constant, no? Para makuha nato ni. And then where k1, so k1 nato is always f of xi and yi. And then k2 nato, we will just substitute the value of a2, then b21, no? So we have this 1 half h. Okay, and then B21 is also equal to 1 half. So, manang 1 half K1 siya, H. So, whatever the values of K1 here, we will just substitute it here. And then K3 equals to F of Xi plus H, Yi minus K1H plus 2K sub 2H. Kana siya. So, substituting lang atong mga constants niya. Okay. So, next is the fourth order Runge-Kutta method. So, same gyapon, madungangan lang siya gyapon ang iyang general formula og C4K4, no? So, mana siyang madugang sa iya. So, since na naman tay K4, we will also have an equation for K4. So, K4 is equal to f of xi plus a4h, then yi plus b41 k1h plus b42 k2h plus b43 k3h. So, this numbering, no, na makita ninyo b41, so it means this is representing b for K4 multiplied by K1. So, man ang B41 siya because it involves K4 and K1. Okay? Just like sa K3, it involves, B31, it involves K3 and K1. So, man ang B31 siya. So, B32, it involves K3 and K2. So, B32. Okay? Same also with the other. So, K4 and K2, so we have B42. K4 and K3, so we have B4 3. So those constants C2 C1 C2 C3 C4 A2 A3 A4 B21 B31 B32 B41 B42 and B43 depends on the methods used, no? So, for classical fourth order RK methods, C1 is equal to 1 over 6, same gyapon sa atong third order. But different na siya sa C2 because our C2 will become 2 over 6 or equal to 1 third. C3 is also equal to 1 third. And then, C4 is equal to 1 over 6. So, you will, atong C2 sa una na 4 over 6, imo siya gibahin kaduha. And then, ang C3 na to is nahimo na siya C4 which is 1 over 6. And then A2, A3 and A2, A3, A2, B21, B32 is all equal to 1 half. And then A4 is equal to B43 which is equal to 1, B31, B34, B41, then B42 are all equal to 0. And then same method, we will be just substituting the constant to the general form. So that is yi plus 1 is equal to yi plus 1, 6 multiplied by k1. So, gigawas na lang 1 over 6 dire kay common naman siya ang 1 over 6 sa tanan mga c's. So, muna siyang kini 1 times k1 plus 2 times k2, 2 times k3, then plus 1 times K4. So, K1 plus 2K2 plus 2K3 plus K4 times H. So, we're K1 is equal to 4 f of xi yi, K2 is equal to f of xi plus 1 half h, then yi plus 1 half K1 times h, and then K2 is equal to f of x plus 1 half h, then yi plus 1 half K2h, then K4 is equal to f of xi plus h, yi plus K3h. So, ano siya. So, let's have an example. So, diretso na ta sa classical fourth order, no? Kay para ma-apply to sila tanan. Kaya ang second order is tama naman siya sa K2. Sa third order is tama na siya sa K3. Then si K4 is tama dyan siya sa K4, no? So, ang atong example ani kay para ma-wrap up na to sila tanan is just the K4. And then atong may-utilize ang atong time dyan sakto. Okay. So, for example, our RD is same gyapon sa to ganina, no? dy over dx is equal to negative 1.2y plus 7e raised to the power of negative 0.3x. Okay. So, we have this initial value, 0 and 3. And then the step size is still the same. So, our step 1, so same gyapon. Then, we will solve for x2. So, still 0.5. Okay. So, we have our K1 using the formula, no? So, K1 is just the function of xi and yi. So, that is simply negative 1.2 or the derivatives, no? We have dy over dx. So, negative 1.2 y1 plus 7e raised to the power of 0.3x1 equal to negative 1.2 times 3 plus 7e raised to the power of negative 0.3 times 0 equal to 3.4. So, by simplifying it, we have this 3.4. And then for x1 plus 1 half h, no? So, these are the values to solve for K2, no? For K2, so we have, because we're going to solve for we will be substituting this value, no? Sa atong f of x para ma-solve na to ang K2. Tama? So, x1 plus 1 half h is equal to 0 plus 1 half 0.5. So, we will just substituting the value. So, we have x1 being equal to 0, h being equal to 0.5. So, that is equal to 0.25. And then, y1 plus 1 half k1h equals to, y1 nato is 3. Then, k1 nato is equal to 3.4. Then, h nato is equal to 0.5. So, simplifying kini siya na expression, we have 3.85. So, then, para ma-solve na tong K2, we will just substitute these values sa atong function na f of, na negative 1.2 y plus 7e raised to the power of negative 0.3x, no? So, kung say value na itong makuha dira no? Mo'y atong x, kini. Then, mo po ning atong ibutang po nga y. So, as you observe, kining y1, nahimo na siya y1 plus 1 half k1h. So, mo ni siya na value. Then, ang atong x, nahimo na siya x1 plus 1 half h. So, ato lang siya i-substitute dira. So, and then, since we have already solved for the values of this, no? These two. So, we will just substitute it. No? So, y1 plus 1 half k1h is just equal to 3.85. So, mahimo na ni siya negative 1.2 times 3.85. Same also with x1 plus 1 half h. Ato siya substitutan og 0.25. So, mahimo na ni plus 7e raised to the power negative 0.3 times 0.25. Okay? We will just substitute it with the 0.25. And then simplifying this expression, we have 1.874. Okay. Then to solve for K3, we will now use y1 uh, y1 plus 1 half K2h, no? So okay, so kana siya, no? So same lang gyapon siya og value, no? So we will just simply substitute y1. So, we have 3 plus 1 half times 1.874 times 0.5. So, which is 1.874 is just K2. So, simplifying this expression, we will have 3.469. So, pagkamandayan, ato na dayon siya i-substitute sa katong function. No? So, function na to, is for K3, ang atong Y will be Y1 plus 1 half K2H. No, which is mo na siya ang atong gisolve, mo na ang atong gisubstitute po na siya diri a. And then karon ang atong X is X1 plus 1 half H. So si X1 plus 1 half H is just this value. Okay? Kana siya. So this which is equal to 0.25. So mo na dahil ni siya, we will just simplify this, then we will have 2.331. So next for K4, we will just solve for Y1 plus K3H equals to 3 plus 2.331, 0.5 times 0.5. So that is simply equal to 4.166. So substituting the value of y, which is y1 plus k3h, because manang nawalang 1 half because of the value of b43, no, which is equal to 1. So k3h na lang na siya. Then plus 7e raised to the power of negative 0.3 times x1 plus h, no? Kana siya. So then substitute na lang po na ito ang value. So uh, x1 plus h is just simply x2, no? So mo na pag-substitute na to diari, na mo na ni siya negative 1.2 times y1 plus k3h, which is equal to 4.116, mo na siya 4.116 plus 7e raised to the power of negative 0.3, then multiplied by this value, which is just equal to this, no? Mo na siyang 0.5 na siya diraa. So ato ra na simplified expression, mahimo na ni siya 1.026. Okay? Sige. And then, to solve, ang atong man yung tuyo is to solve for the y2, no? Kaya para sa atong step 1. So, sa step 1 pa ni siya, no? So, ingato na kata sa atong gibuhat. So, okay, kana siya. And then, we will just substitute na ang atong mga values. So, ang atong y1 is just 3, di ba? So, manang 3 dira, ah. Then, 1 over 6, no? So based on ato formula, no, so we'll just extract 1 over 6, no, sa common multiples ni sa mga c's, no. And then K1, so K1 is equal to pila tong K1, 3.4 kana siya, 3.4 plus 2 times K2 nato is equal to 1.874, so 1.874 na siya. 2 times K3 nato, so K3 nato is just 2.331, so 2.331 na siya dira, ah. Then K4 nato is equal to 1.026, so 1.026 ni dira, ah, no? And then multiplied na sila tanan sa 0.5, which is mo na siyang atong H, no? So which is gi-extract na nato siya earlier sa atong formula. So then simplifying this expression, we have 4.069. Okay? So it means that our x2 and y2 is equal to 0.5 and 4.069 respectively. Okay, so for step 2, we will be doing same methods but different values of x3 and y3. I mean, different values of, instead of using x1, we will be using x2, no? And then instead of using y1, we will be using y2 based on the values solved from the step 1. Okay? So, same method, then we will arrive to this answer, no? Kana siya. So, okay. Next na po na siya. Hantod mabuta sa step 5. So, kini siya step 3 lang siya tama ng gibuhat diri, but dapat mabot pa ni siya og step 5, no? Kana siya. So, kung ato siya input, no? Kini step 3 lang gigamit, no? So, kung ato siya input, almost exact na siya, no? Wala na siya difference in comparison with the previous nato na mga methods, which is the Euler's method and the modified Euler's method, no? So katong sa modified kay napad jud siya gamay na kang ano dira. Pero pagabot sa fourth order na Runge-Kutta, wala na, no, almost wala na. Okay, so kana siya. So kana siya, no. So this is the Euler's explicit method, then this is the Euler method. So naa pa siya gamay na kang no? Then si Euler kay grabe jud kalayo, although na subay niya ang iyang form, but layo gihapon. Pero pag-abot kan Runge-Kutta, grabe jud siya kapino na, no? Almost equal na siya. So, any more questions before we end our discussion?
Excuse me, sir.
Yes.
Kuan, sir, kanang about sa finance, sir ba? Possible ba na tanan mo gawas, sir?
Possible ba tanan mo gawas?
Oh, kanang karon, sir ba? Ta,
Actually,
module
we,
like.
we are still working on with the top. Actually, tanan gyapon topics is involved, no? Kay TOS based man ta, so it means na every module is involved yun sa question, just like what we do in the exam, no? Just like what we do in the midterms, no? Na every topics na check corresponding question. But the problem is asa ka na example sa every topic magkuha. For example, sa module 11 unsa kay problem na ibutang Runge-Kutta ba ka, ordinary equation, kuan ba ka, ordinary asi tawag gani, Euler's method ba ka, or modified Euler's method ba ka ang ibutang. So we will still be deliberating if we will provide specifics, no, with regards to pointers. No, we will be deliberating with the other faculty kung siya ngayon na, no, kay based on man god, application dapat ang pag-apply man god is dapat mahibalan jud na ninyo, tunan jud na ninyo. But given na nanay formula, no, which is most of the students, as I observe sa inyong results sa inyong exam, given na ganiyang formula, di pagyapon ka balon saan siya paggamit, which is important sa inyong sa inyong learning, no? Yat mura nagingani ba? Yatagan musalang musgira, yatagan mo armas, unya di gyapon mo kabalon saan paggamit sa inyong armas na nagani mo yung armas, di ba? So dapat matun-an jud na ninyo sila tanan. Karon hatagan ta mo og tips unsaon ninyo na siya pagtuon tanan nga dili maglabad kayo inyong ulo. Um inyo siyang subayon jud. Subayon jud ninyo siya. Just like sa Runge-Kutta, medyo taas-taas siya, no? Ang pag-solve sa iya sa mga values, no? Taas-taas jud siya as in. Ang mahimo natoan na nga buhaton, um i-familiarize jud ninyo ang ang iyang method, no? So actually kuan raman siya, um by kuan raman good ang una. For example, una jud nimo engineering kwanta, no, methodology in solving problem. Kay kita engineers, and you being future engineers, di ba, we will be dealing problems, and we being an engineer and you being engineer soon, being an engineer in the future, maybe soon or sooner, um, dapat kabalo ta mag-deal sa problem. So unsa na to pag-deal og problem? So we will be seeing what is the purpose una, no? Una tanawon sa nato unsay problem. So unsay gipangayo kita mingon siya na ODE ang problem. So unsa na method ang gamiton kay identify dito na Runge-Kutta. So balik na tanaw dayon ka sa formula sa Runge-Kutta. Unsa man ang formula sa Runge-Kutta ba yun? Unsa man na dito sa Runge-Kutta? And then pag-ingon na classical, unsa kay mga constant sa classical Runge-Kutta? And then given na natay general form sa Runge-Kutta, unsa na to na siya pag-input tong mga constant dito be, para ma-solve na to ni siyang mga k og y itself, no? Unsa na to siya pag-solve? Maka-formulate tag formula gikan sa Runge-Kutta. Ingana ang inyong approach, no? So bayan ninyo, base mo sa problem, tanaw din mo sa formula, kung pwede na o gamiton ani. And then kung diha jud ma-test kung nagtuon ba jud mo, no? Kay kung kintay hatag na namo daan ang inyong ang inyong tawag na si Manggawas probably, mura naman naghatag daan sa inyong question, no? So murag dili ma-test, walay murag mahulog na useless ang assessment, no? So ingana po amo pa nang i-deliberate kung kinahanglan ba na ang pointers is necessary ba na specific kung sa na problem, no? So kana siya, natubag bang pangutana?
Yes, sir. Clearly
Mm.
kay sir. Thank you, sir.
Nga na siya, no? So I think murag sa karon murag na ano, ay grabe bugat kayo. Ayon na nauna nang kabugaton. I-try sag buhat, no, atong akong suggestion. And then adisar pa mo feedback sa ako kay most of the person pud nga gareklamo nga na nga atong wala cancer is dili pud enough ang ilang pagtuon, no? So kisay gusto mo defend sa iyang kuan, nasakto na ang pagtuon sir, kisay mo defend be, willing isog mo defend diya sa iyang part, no? So it means na sa inyo na self nga, it means na dili pa di enough akong pagtuon, no? So ingana na siya, man dili ta mag-rely nga kuan, although given nga natay laboratory na makapasar ta, kay I know, no, dili man jud sa kanang sa laboratory ana, I think one or two person ra jud ang ga-workout ana in terms of solving solution, no? Ang uban na sa presentation na ng kuan na, tama ba? So in terms of kuan, in terms of kuan na, in terms of learning ninyo, dili gyapon siya effective, no? So mo nang na exam kay para makita gyud kung kinsa jud kay balo, no? So which is na found out na ako sa exam na uban naka 8, ay yatagan na lang na akong tig 2, 3 sa kada question, although wala jud na human ang answer, no? Eh para at least magka-score lang. But given nga nasugdan man gyapon ang solusyon, no? As long as nakasugod siya na padulong siya dito, just like I've said sa atong first na meeting. Pag nga na iskoran gyapon ako na siya. Pero kung halimbawa kuan jud naga na siya gisulat pero murag gi-copy ra tong question, wala na siya score, no? So which is bad sa akong kuan impression sa inyong performance, no? So sa karon since kuan siya summer, no, mid-year siya, medyo log-log lang ko in terms of strictness sa pag-score, no? So kana, so which is nakatabang-tabang man pud sa inyong score kay sa 2G, which is naumanan na ako siya og compute, no, na na-post na pud na akong ilang grade. Nakapasar gyapon to bisag ang uban bisag kuan kanang gamay sila o tawag ani exam kay nabawi sa ilang midterms. And unta na dili nga na nga atong kuan kay ang midterms is mao naman jud siya ang atong assessment. Kay supposedly dapat kanang midterms nato sa lecture, mao na pud na siya ang midterms nato sa laboratory. Pero kung halimbawa ingana ang among buhaton manggod, walay siguro 30 or 20 to 30% lang ang makapasar. So roughly na siya sa mga pila na siya kabuok, 20 to kuan 30. So 8 to 12 persons lang ang makapasar sa midterms. So gitry na ako na siya solve gamit ato na formula nga supposedly dapat kung sa midterms ninyo sa lecture mo na pud ang inyong midterms sa laboratory. So mo ato ako na find out. So akong gi-propose with the faculty na kung say result na lang sa inyong laboratory, i-half na lang to siya. Ay murag average na lang to siya both sa hands-on in the kuan tawag na hands-on in the laboratory reports. Kung sa average sa nila mo na lang pud ang inyong score sa um, laboratory exam. So which is na pasar man pud sa 2G tanan is pasar, no? Although gamay siya kuan. Naiuban nga 2.75. I think ang pinaka small na grade is 2.75. So si 2H I notice na almost same sila grado tanan. Wala difference. Tinabanga siguro ni sa ka-section isa ka problem, no? Sige, so I think okay man pud na siyang collaboration, no, but I hope na in terms of learning is mag-collab pud mo kay kanang mag-workout ra mo sa isa ka problem nga kamutanan mag-collab mo, ang learning manggudan na mawala manggud kay isa ra trabaho unya output na sa tanan, so which is dili na helpful sa inyo, no? So I suggest mo mag-groupings manggud manggani mo, magtinabanga na pud mo sa pag-learn, no? Kung mag-groupings na mo, mag-study na pud mo ana, idungan ninyo nag-study, no? Ingan na ako suggestion kay para dako gyapon natong score sa exam. Kay pag-abot man gud sa uh, pag-check sa atong programa na sa civil engineering program, ang gina-check man gud na isang exam, no? So if nakapasar mo unya gamay mo exam, ang impression na sa atong program is pangit, no? Kay ngano nakapasar man ni sila, yun sa manimo ni pag-monitor. So in terms of kuan performance sa department, very bad na siya na impression. Okay? So tabangan nato ang atong department nga mobalik ang iyang dungog, no? Given nga sadly, no, so frankly speaking, no, tanaw na tong result sa board exam, gamay kayo ang percentage, almost less than 50 ata percent ang nipasar sa board exam. So sa nga na case, no, given na daghan kayo mo civil engineering, bad na siya na expression. Impression, no? So bawion nato na i-kuha na to, i-convince na to kagalingon nato na bawion, no? Na dapat basta graduate sa USTP na civil engineering, manoy jud, no? Passers sa board exam. Okay? So, okay. So, any more concern? Last? Wala na? Or na hands up? Yes, unsa man Brian?
Sir, pwede nimo utro tong na-announce nimo mga final activities, sir? Like katong PITs, tong quiz,
Okay.
katong upcoming, sir, nga activities.
Activities. Okay, so for quizzes, ang required man gud sa at least 3 quizzes ta, no, sa atong sa atong handbook. So for 3 quizzes, pahinon lang for Wednesday, ang atong topic na is numerical differentiation o numerical integration, no? So same gyapon natong format, mag-start siya, ma-post siya by 1 PM kay na daw may activity ana with the result. Tama ba? Og CMT na daw may activity ana by Wednesday next week. Tama ba?
Yes, sir. Case
Okay.
studies, sir.
Kana siya, no. So para dili na to na siya, para makuan mo maismo ana. So same gyapon natong kuan, atong method, no, sa kuan 1 PM to 10 PM gyapon. So let's say mahuman mo by 6 PM sa inyo, posible na na mabot og 6 PM, no. 5 PM na siguro na tama ng inyong case study ana. So napa mo'y 5 hours to solve for the quiz, no. Kana siya. So and then same gyapon 10 PM na gyapon siya extension na 30 minutes for the submission. Okay? Ano siya? So it means na mag-close jud siya by 10:30. But don't put in mind na nga na siya mag-close. No, kay para kay we don't know basin um mawala ng signal ana, mawala na nga na ng mga reason, no? Kay na naman tay 30 minutes na extension. Okay? Sige, so by Thursday, mo na ning atong gidiscuss karon last, which is ODE. So natay tulo ka methods, no. We have this Euler, modified Euler, and then we have this Runge-Kutta. Okay? Yan na siya. So next dayon isang laboratory. So probably later on mas ma-post na nako na siya. Single activity lang siya. Single ra ang manual, but tulo na siya ka activity involved. We have this laboratory 4, then laboratory 5, and then we have PIT 2 dayon, no? So which is inyo na sa i-submit by Monday. Maybe Tuesday na lang kay para na may 1 day extension to do the one. I-submit ninyo siya by Tuesday. Next week. No, Tuesday. Ano sa man ang day ng Tuesday? Next week. Next week is sa man na adlaw? It's 6, no? So 6, so 2 plus 14. So 16. Oh, 16. So dapat masubmit na ninyo siya by 16. So no extension na siya, no, kung sa J1 na mo na jud na siya ang date. So bali ang pinaka end jud sa atong kuan is Monday jud siya supposedly, pero due to extension sa submission maghatag ko 1 day, no. So Tuesday mag-close jud siyang form, no, wala na siya extension. Okay, Tuesday 11:59 PM mag-close ng form kay para napakoy time to check for your outputs. Okay? Kay ang submission sa inyong grades is by 19. So, na lang ko 3 days na to check your outputs. Given nga 3 pod mo ka sections and then 3 pod na siya ka activity. I think that it is quite short na para sa ako to check that. Then plus na pa may exam, no? Sige, so okay. So initially ang atong exam will be on Saturday next week, no? So, kana siya. Okay, so mo to siya ang atong mga activities. Any more question? Sige, Brian.
Sir, i-clarify lang to na ako katong gi-announce nimo earlier, sir, nga duha ka groups nga murag emerge nimo. Unsa
Yes,
to siya, sir?
duha na mo ka groups bali na immerse ni nako no sa activity ninyo. Bali na I will send list no sa kung saan na mga groups ang akong immerse per section. So let's
So,
say
mo na ni sa lab report and sa PIT, sir.
yes, bali mag-isa na lang mo og output no per two groups. But same gyapon ang atong kuan no ang method sa peer evaluation by group gyapon no by group gyapon siya per single group, but the output is one output for two groups no. So na siya output for laboratory 1, I mean 4, na siya single output lang ang duha ka group sa laboratory 5 and then sa PAT. Okay, sige.
Yes, sir.
Sabtan na.
Thank you, sir. Yes, sir.
Okay, sige. Another question, last na questions na akong i-cater before ta mag-end. Sige, Hubert. Hubert? Hubert? You? Hubert? Sa man, ay question wala?
Nag-talk siya, sir. Nag-talk.
Aha man. Wa ko dungog. Dili na ako madungog yung tingog.
I-chat na lang.
Hala.
Magatag pa daw
Guys,
ka og, ano sir, kanang
Yes, magatag
formulas
gyapon ng
gyapon
formula.
sa exam.
Gatag gyapon ng formula. Then ang kuan lang jud ana is ang inyong application jud kay mao man jud na sa actual field, di ba? Unsa given na naamoy formula da, unsa ninyo pag-apply sa formula? So, in terms of kuan, formula na jud na siya yatag na namo. No. Okay.
Excuse me, sir.
Yes.
Kasa ka mag-release og score sa concert sa 2H?
Later on ako na siya i-release. Nara ko gi-check gamay. Gamay na lang pud ni. 2H ug 2I, ako na siya i-submit later on. I-release ron na ako na siya.
Thank you, sir.
Sige. Okay. I think that's all na, no? So, thank you for attending our class. But before we end our discussion or our meeting, kindly turn on your camera so we can have our screenshot. Hindi lagi makita ang camera. Binuang lagi na yung camera. Nangyari. Sige lang. Okay. Smile guys. 3, 2, 1. Okay. Sige. Last one. 3, 2, 1. Okay. Thank you guys. Thank you. See you on Monday. Kung kinsa may mga 10 or Tuesday ba. Bye guys.
Thank you, sir. Goodbye.
Bye, sir. Thank you, sir.
Thank you, sir.
Goodbye, sir.
Goodbye, sir. Thank you, sir.